right, so I'm going to run through a quick Python refresher. Believe it or not, these 17 slides will get you most of the things you need in order to be able to follow along, hopefully. If you have some familiarity with programming languages in general, you know we're going to start reading our code top to bottom, left to right, following the rules along the way. So in these 17 slides, it's really more about the syntax of Python rather than an introduction to computer science, breaking a problem down, all the other kind of good stuff. So there's some instructions here. It says go to this website, https://repl.it, and create a new Python 3 REPL. What do I mean by that? If I click that link, follow it, you'll land at a website that allows you to start writing code in your web browser. You don't need to install any tools or anything like that necessarily. If you just wanted to start, approaching programming in Python. Later on, we're going to actually install Python and going to write code that runs on our computer as opposed to writing it in such a way that it runs on some web browser, right? So fortunately, we're in this Kali Linux installation. What you can do is if you'll, I think I can zoom in. Maybe I can, maybe I can't. Oh, no, it's not doing it. No, it's still not doing it. Anyway, if you look up here and you hover over, you'll see the terminal emulator. If you'll click on that, you'll get this little black box that shows up. I'm going to zoom in on mine using the same shortcut you use for Chrome, Control-Shift+, or Control-Shift equals, I guess, to get the plus. And that's going to zoom in. If you'll type Python 3, you'll end up with what they call the Python REPL. This allows you to sort of interactively run code. I can say 1 + 1, and it should give me the answer 2. I can say variable name here equals is assign the result of the expression some value, which happens to be a string, which contains some value. If I want to put something onto the screen, I simply print variable name here, whatever I called that previous bucket, and it puts it onto the screen. All right, so I chose to go this route because that's where we're going to spend most of our time for the most part. One thing I will do is we should have already installed Visual Studio Code. The way you can access Visual Studio Code, this is going to give us our IDE experience, our integrated development environment experience. If you'll click on the Kali icon in the top left corner, it looks like a little dragon, and you just type code, C-O-D-E. You should see the option for Visual Studio Code. If you don't, go find the other video where we install Visual Studio Code, and you should be in a good spot then. All right, it opens up. By default, you're on what you have to do is create a new file. It's gonna present you with like a welcome page. I'm gonna hit File, New File. And right now what it's asking me is it's saying, and let me zoom in a bit here too so you can see that, it says, oops, too far. Oops. It says select a language to get started, start typing to dismiss, or don't show this again. If I start typing and then erase it, it's going to come back. If I never want to see this message again, I can do that. If I want to pick a language, I can click this, and it's going to give me a list of languages that it kind of has a very loose understanding of right now. Because we've already set this up for Python, if we just type to like sort of search, you notice that we could type Java. Oops, there we go, Java. It's going to only show things that contain the word Java. So I'm going to type Python because that's what we're going to write, Python. And notice that it's gone away. Over here, it says we're running Python. It knows we're running a version of Python, but it's the old version. We don't want to use this version anymore. What we can do is we can hit the little icon that says Python 2.7. Yours might be something different, 1.8. It's going to pop up a little sort of interactive window right here. It says select interpreter. I want to hit Python 3.9.2. We'll do that. Okay. And it's loaded the Python extension, Visual Studio Code. This is like our IDE now. You can tell it not to do this again. This is not what you have to do every time you write code. This is just like configuring your piece of software the first time you open it up. Because this might be the first time you open this up, right? So it's giving you some hints here. You can create a new Python file. we've created a Python file right here. What we can do is start writing our code. You know, we could do whatever we want to do. Wait, we don't know Python code yet. Let's look at our slides. So now that that's open, just understand that it's a window just like that we can sort of jump between, just like all the others. We have a taskbar along the top here by the clock. I can click on my slide deck right here, and I'm back at my slides. So what are we going to look at first? Let's look at a basic overview of the various data types and data structures, the simplest data structures in Python, as well as how to create a variable, what can be put into a variable, and basically how to write variables and like write lines of code. So you can see here on line 1, we have a variable whose name happens to be the letters O-N-E. We assign it with this equal symbol. We assign it the value, which is the result of the expression, which is just the bare assertion 1. That was a complicated sentence for 1 is assigned the value 1, right? But what's useful about saying it that way is that it's true of every variable declaration. There is a variable named list of things who is assigned the result of the expression, which happens to be the assertion of a list. There is a list that contains an element, which is a bucket whose value is currently 1, the bare value 2, and the bare integer value 3, right? All I'm saying is that there is a list of things, and here's how you define a list. You put these curly braces around it. You're never going to have just one curly brace by itself. You're always going to have a sibling set. So you have an opening curly square brace and a closing square brace. All right, now that I've got some basic variable, some more complicated variable, you'll notice that this variable is a list or collection of other values. It's holding a bucket itself, right? It is like a row of buckets where each bucket can contain other values. One is this variable named 1 is a bucket, and it holds 1. And list of things can not only hold values, but it can hold other buckets. Think of it that way, okay? So now we're going to do something with a bucket. Python's very friendly, and it lets us just kind of cleanly dump buckets onto the screen. Print is how we do that. And following the rules of PIMDAS, right, we do everything in parentheses first. So if you want to put something onto the screen, if you want to do a function, you have to use parentheses to invoke it. So we're going to print onto the screen the current values that are in the row of buckets known as list of things. That's how I'm reading that sentence on line 3, right? As if it was another human language. I'm reading that line of code. Put onto the screen the current values of the variable named list of things. That easy. Now, I can change the list of things. This is kind of analogous to an array in Java, in the sense that you have an index, you have a 0 index, a 1 index, a 2 index, and basically you start counting at 0, and you can go up a certain number of things. Unlike Java, you can continually add things. Once you've created an array, it's not really fixed in size. At this level, it's not fixed in size. You can add things to it, you can remove things from it, and so it's dynamically sized. It's big enough to hold whatever you want to put in it reasonably. So I'm just showing you on line 4 a different way to create a list that's maybe a little visually more appealing. It allows you to sort of spread things out a little bit. Right? If I had, imagine a long, complex list of names, rather than looking at them in a single line like this, that might be visually hard for me to see. I can technically split it up as long as I follow a couple rules. I can split it up across multiple lines as long as I follow a couple rules. The first rule, I say rule, it's a rule of thumb, if you will. I like to have my square bracket at the end of the line. And then as I hit enter, I should get pushed over automatically. I have to come over one layer of indentation. So you've heard that maybe Python is white space oriented, or it cares about indentation. The The reality is you should care about indentation in just about any programming languages that you're teaching. Some languages don't enforce it, but it really does go a long way to help you keep visually organized. So I'm creating a new list of things. I have a bucket named list of things already. Doesn't matter that I've emptied out that bucket and I'm putting new stuff in that bucket. Not a problem in Python. They don't even have to be the same type of things. You'll notice these are all numbers. Now we're talking about words. Now we're talking about decimals. Now we're talking about hexadecimal values. It doesn't matter. Python will just allow you to put whatever you need to in that bucket. What I've done is I've added a layer of indentation for each item. Now notice I still have my commas to separate all the items in the list. This is a string. It's the letter CAT. This is a special kind of string. It's called a byte string. And it doesn't allow you to use, it's basically where each character, it looks identical to, you know, this string up here, except for the fact that these are technically Unicode characters and these are technically byte characters, which happen to have Unicode representations, which happen to fall in the ASCII range that we recognize as the shape D, the shape O, the shape G. It's useful if you're trying to write to files or to the network because they operate on bits and bytes and humans operate on Unicode and the visual representation. So, or the shape D, which represents the sound, dog sound, okay? Just raw byte values. If you're reading and writing to files, you're generally going to be using raw bytes. Reading and writing to the network, generally going to be using raw bytes, not just regular strings. Next, and make sure you have your comma there. Next, you have 1337. This is a decimal value, okay? I can have mixed data types. Not one of these is the same. This is a string. This is a byte string. This is a floating point. And this is a hexadecimal value. You can tell it's hexadecimal because it's prefixed with this 0x. You'll see that a lot dealing in cybersecurity. You'll see 0x something, something, something. That's denoting that it's in hexadecimal. If you're concerned about, you know, what that value is 4,919 apparently in base 10, okay? So I've added all of these items to the list. I want to end my list. That's the end of my grocery list, my shopping list, my recipe ingredients list, right? It's the things that I wish to have stored next to each other. I remove my layer of indentation and I close my square bracket. It's that easy. This is, again, if I had a lot of items and I kind of wanted to see, imagine this was a really long, complicated person, like name, right? First name, last name, and then I had a whole 25, you know, set of students. This is not a great way to look at it. This is a little bit better. Now, same thing is true. I want to put this list of things onto the screen. All right, I've talked to you about the code. Let's write some code. I'm going to open up my Visual Studio Code, just again, by clicking on it. We already opened it earlier. And I can I could literally copy and paste this. I can copy and paste it. That's lazy though. You won't learn a whole lot doing that. You'll develop muscle memory by actually doing it. So I'm going to create a bucket named, I'm going to push this window over to the side. I'm going to create a bucket named some bucket. What is a bucket? It's just a variable. It's a place to put values. Some bucket equals, or it's assigned the value Eli. My name is in this bucket, okay? Next, I'm going to create a list of people. List of people is assigned square bracket. I'm going to put in some bucket, right? Doesn't matter what this is called. It'd be great if I gave it a reasonable name, like person one or my name, something that represents what the value inside of the bucket is, but you don't have to. There's no law saying you have to do that. So I'm putting some bucket. I'm going to put a second person in my list. I'm going to call the second person Thomas Jefferson. Okay, it doesn't matter. $20 bill. That's what we're looking at here. Who's another person I can add to my list? I'm going to put on wallet. Whose wallet? It's not a person, it's a thing. I'm looking at my wallet right here. It doesn't matter what's in the thing called list of people. It doesn't make any sense to call it list of people if it doesn't contain people. Keep that in mind. Give your variables appropriate names for what they're containing. I'm going to change wallet to walless and grommet. Okay, so list of people. So this contains 3 distinct people or variables or values. Conceptually, that's what it contains. It contains the current value of some bucket, which happens to be Eli. It contains a value that happens to be Thomas Jefferson. It contains a value that happens to be Wallace and Gromit. And you'll notice that my word wrap is on, or it's not on, so you're seeing the line kind of scroll off the screen. I'm gonna turn it on really quickly. I'm gonna go to View and then toggle word wrap. Now notice that as I hit the keyboard shortcut for it, what's happening is that it's hitting the edge of my window and it's wrapping around. Notice that the number 4 is right here. Now there's a gap between 3 and 4. This is still on the same line technically. According to the file, to the data itself, it's still on the same line. Visually, for me, the human, it's split across 2 lines, but to the computer program, it's on 1 line. We have 1, 2, 3, 4 lines of code, not 5 lines of code. All right, so how do we do something with this list of people? What do I want to do? I want to print the list of people. Cool. All right, how do I run this program? So far, I've just typed it. There's no go button. There's no, on REPL, you'll have a nice big green button that says run, except that runs on some other computer that you don't control. You want to run it on your computer. We control this computer. I'm going to have to save it somewhere before I can run it. I'm going to hit Control S to save. And it's given me a suggestion for a name, and it just so happens to be the first line of that file. It says sum_bucket equals eli.py. That's not a great name for the program. Let's call this learning Python. Learning _ Python .py. The .py is kind of important, kind of not important. It helps remind you that this is a Python file, but the computer doesn't really care a lot. And where is it saving it to? By default, it's saving it in a place called your home folder. That's the folder that contains your desktop, the folder that contains your downloads, the folder that contains your pictures and other things like that. So I'm going to hit save. I'm going to hit save. All right, now what do we do? Oh, all of a sudden, we do have a green button that we could hit. And it's going to say run Python. If I hold my mouse over it, it says run Python file in terminal. Okay, I'm going to do that and see what it does. It's very nice. It opened up a new little terminal for me, and it has done everything that I told it to do. What did I tell it to do? I said, create a bucket named SomeBucket, put in it the values ELI in a string, create a bucket or a row of buckets, a collection of buckets, a list of buckets, named list of people, assign it the values, the current value of SomeBucket, which happens to be Eli, the value Thomas Jefferson, the value Wallace and Gromit. That's the end of the list. Put that list onto the screen. Notice that we didn't see a bucket named, like when it runs down here, we didn't see SomeBucket equals Eli. We didn't see list of people. We see the contents of the bucket, not the buckets themselves. Okay? All right. So what am I talking about with this number right here where it says list of things? What does that look like to actually write that? Learning Python. Let's go back to our program up here. We can leave this alone if we like. It doesn't have to change. It can just kind of stay right there. If we need some more real estate on our screen, if we need to see more code at one time, we can do that. What I'm going to do right now is I'm going to type, I'm going to create list of things. And this is going to be our multi-line list, a list that spans multiple things. Actually, I'm going to call it not just things. Let's start using some vocabulary that maybe will list of servers. right? We have a list of servers that we are going to consider targeting to do something. We have a list of servers that we want to hack. I'm going to create my first item, and this is a string. We're just going to create names for them. So this is going to be server, let's say web server 1. I'm going to create another server in this list of target servers. It's going to be given the value database server 3. Why is it database server 3 as opposed to database server 1? It doesn't matter. It's just a value. It could be any database server that you want to talk about. It's just a value. What if I wanted to put in dog? Perfectly valid. Is it a server? No, it doesn't make sense to have a dog in a list of servers. So let's see here. FTP server. Every time I add a new item to the list, I'm hitting enter and adding my comma. Let's see, what's another one? We have an email server. Okay. All right, so I'm jumping around here. Notice that when I typed this square bracket, it automatically added the square bracket for me. That's not Python, that is the IDE. That is Visual Studio Code being nice to us and helping us not break our wrists by having to type a bunch of characters like repetitive motion over and over again. So I have a list of servers. What am I gonna do with the list of servers? I'm gonna put them onto the screen for right now. Print lists of servers. All right, what's that gonna do? What do you think? Boom, it put it onto the screen, the list of people and the current value of list of servers. Web server 1, database server 3, FTP server, email server. That easy. Cool deal. We've exhausted this slide. So that's one slide down out of 17. All right, so this one here is super powerful. We have a list of things that we're gonna do. And what we're going to, the way that I like to sort of conceptualize this is I always say for item in singular item in plural items. That's how I read line 1. For everything in list of things, for every person in list of people, for every person in the list of people, do all of these things. How do I know all the things to do? Because they are all pushed over the same amount and they're all like right next to each other right here. So let's look at what all of these things do here. This kind of assumes that all of these things are strings. And so I think this will work. We can get the uppercase version. It doesn't make sense to get the uppercase version of a number, right? So there is no upper if you're dealing with if thing happens to be a number. This for loop doesn't really care if they're all the same. It's going to try to do everything to each one at one time. So it's kind of up to you to do something that makes sense with the values you're dealing with. That's why you don't want to mix numbers. And well, it's not that you don't want to. Be mindful about mixing, numbers or quantities with, string representations or words. So what are we going to do? What does this thing do here? It says for thing and list of things. Try to print the uppercase version of it. Try to get the string representation of it. If it's the shapes 1 and 0, try to turn that into a quantity, an integer quantity, and then try to get the hexadecimal representation of an integer quantity represented as a string. That one's kind of complex. We're probably going to, it's not that we need to skip it. We're not going to skip it. Let's do it. Let's make it work. All right, so I have a list of servers. So let's make this for loop kind of come into fruition. Let's push this over to the side. Can I do that? 100%. You can still read that. We can read it right here too. Great. All right, so how does this work? I say for, what are we dealing with? We're dealing with a list of servers. So for every server in the list of servers, what did I just do there? You notice that I got that little pop-up. I said list underscore, and then I had things I could type. Like this is the IDE doing it for me. It's not Python. It is the IDE, the tool Visual Studio Code helping me out. I'm gonna go ahead and type it out by hand. List of servers, like that. All right. Now notice that I have this colon. This colon combined with a layer of indentation is what signals to Python that you're in what they call the scope of the for loop. You're inside of the for loop right now. I'm going to hit enter. Notice that it automatically pushed me over 1, 2, 3, 4 spaces. Generally, 4 spaces is what they call a layer of indentation. That is indented a certain amount. Can you get technical and do only a single space? Yes, you can. All that does is make it more complicated on you because the tools by default are configured for 4 more often than not. Sometimes you'll see them configured to be 2 spaces, but a lot of times you'll see us set up to be in 4 spaces. That is what they call the tab character. That's that tab character on your keyboard. A lot of times they're set up to either be the single tab character or 4 spaces, 4 presses of the space bar. 1, 2, 3, 4. All right, so for every server, what do we want to do? I want to put onto the screen that server's name, just to start with. Let's try that. Print, put onto the screen, server. Let's see what that does. I'm going to hit my green button here. Notice all the lines that actually do something right here. Puts on screen. That puts something onto the screen, that puts something onto the screen, and that puts something onto the screen, right? We've got almost 20 lines of code here, but only 3 of them put anything onto the screen. I will note, and I'll say that I think it's worth noting, by default, it assumes when you put something onto the screen that you want a new line after that, that you're done putting things on that row on the screen. So you'll notice that this all shows up on one row, this all shows up on one row. However, when we say do this, every time there's a server in the list, here's a server, here's a server, here's a server, here's a server, 4 times, you're going to put it onto the screen, and by default, it assumes that you're done on that line, and it moves you to the next line. It puts what they call a new line character. There's a way to change that behavior. We'll probably talk about it when we're talking about it in class, but this here is the gist of it. So I'm going to put onto the screen server. What are these other things we're talking about? This thing.upper. What if I typed what if I type thing.upper here? It's going to try to find a bucket named thing. Did we define a bucket named thing? We did not. So it's going to give some sort of error. Let's try it out real quick and see what it does. I'm going to put onto screen thing.upper. Okay. I'm going to save it. I'm going to try to run it. Let's see what happens. Name error. Thing is not defined. It's telling me a couple of interesting things here. Here's my traceback. This is the error page. It's not just it don't work. It's telling you a lot of interesting, useful stuff. It's telling you the name of the file that contains an error as far as it knows. It's telling you where in that file, roughly line 18, and it's even kind of showing you that line, thing.upper, and it tells you the class of error. This is a name error. Name thing is not defined. There's nothing called thing. There is a thing called server. Server. Let's try this now. What is this going to do? I see web server 1, and then I see an uppercase web server 1. Notice that there is no uppercase version of 1 because that doesn't make sense. That's a nonsensical thing to say. Don't say it. All right, let's go print. And then, well, all these other things really have more to do with numbers than other things. Numbers or quantities that aren't exactly what we're looking for. So let's create a new list. I'm gonna show you those things. I think it'll make them a little more sense. List of values. I'm gonna do them all in one line. I'm gonna say the string 10. I'm going to say the string 13. I'm going to say the string 37. And then I'm going to say the string OX, or I'm sorry, I'm going to say, oh, we'll do that 1337. There we go, right there. Okay, so I have 10, 13, 37, and then 1,337. Just numbers. These are shapes, not quantities. This is the shape of a 1 plus the shape of a 0, not the quantity 1 plus the quantity 0, not the quantity 10. This right here on line 20, this is, again, it's like Roman numerals. The Roman numeral for 4 is 4 equals, what is it? IV. Is that Roman numeral 4? All right, so separate the shape of something from the quantity that shape represents. This is the shape of 10, not the quantity 10. This is the shape 13, not the quantity 13. Context matters, right? The context in which we're interpreting this data, these things, matters. And here is where we're applying context. We want to apply the context of a string to some value. So for every value in list, what did I call it? Of values. Again, notice that colon. I'm going to zoom out a little bit. Sorry. When I have that colon, if I hit enter, it's going to push me over. If for some reason I'm in Notepad and it doesn't, right? I don't have a real IDE. It's 1, 2, 3, 4 spaces. It's a combination of those consistent 4 spaces plus this colon that tells Python that now you're inside of the scope. Okay, so I'm going to print val, or I'm sorry, rather the string representation of val. I'm going to print the integer representation of that collection of characters of val. Notice this thing popped up and kind of was in the way. Let's get it right here. And I'm going to print the, the hexadecimal representation right here. This little window, it says hex, I, and it gives you a bunch of other things, return to string. This is IntelliSense or IntelliCode. This is code completion. It's a feature of the IDE, again, not PyPython. And this is just giving you help as a programmer. So you don't have to have all of this stuff. You have to have an idea of what you're looking for. But if you don't remember, oh, is it, the value, the numerator and then the denominator, or is it denominator and then the numerator? Like you can just remember that I'm doing division, and then it'll sort of give you a hint as to what you're looking, how to complete it correctly. I want to put the hexadecimal value of val right there. Okay, so let's see if this works for us. I'm going to hit run. Hex val, str object cannot be interpreted as an integer. So let's check this. What do we have to do? This is a string, not an integer. Hexadecimal is a numbering system. It deals with numbers, not strings, not shapes, not characters. So we have to say the integer representation of val. Wow, we are many layers in right now. So I'm going to close that for a second. I have nested a bunch of parentheses. That looks really complicated, but understand it's going to do everything in parentheses first. What's most in parentheses? Get the current value of val. Well, the first time this loop runs, it's going to be the value 10. So it's like you could copy that the first time it runs. Oops. And then there. All right. It's going to try to do all of those things. And then it's going to scratch this out. Oops, I'm sorry. Now that it knows that this integer representation of that is going to get replaced with the quantity 10, not the shape 10, the quantity 10. It's very important to make that distinction. And then it's going to replace this with 0x. And then I think it'll be a lowercase a. That is the 10 in hexadecimal, right? That is base 10 in hexadecimal. So then it's going to put all of that onto the screen, right? So let us try to run this now. I'm gonna save my code. I'm gonna run it and let's see what it does. Oh wow, we've blown off the screen at this point. I didn't really tell you what these hashtags are. My apologies. I made the assumption that that it should be understood that those don't actually affect how the program works. Everything to the right of a hashtag will get ignored. So what I can do to sort of take some of this old code out of play is I can highlight it, or I could manually go and put one in front of each one. But I'm going to use the IDE to sort of help me out, work quickly. I can highlight all of the code that I don't want to be in play. I don't want it to do anything. And if I believe if I hit the control key and the /, it's going to automatically add one of those comments to me. If I do that, I keep it highlighted right now, hit the /, control /, it sort of undoes what I've done. So if I only wanted to bring this one back into play, I could, or this particular bit of code, highlight it, control / it's back in play all of a sudden. Right here, it has no influence on the program. It's just a note that happens to look like valid Python right now. Now it is, in fact, valid interpreted Python. Right now, it's not in play. It's not having anything to do with the execution of the program. I'm going to save it. I'm going to hit run. I have a syntax error. That's a problem. Where? Let me delete that. I'm going to hit the green button one more time just to find out. Okay, there it is. For some reason, it didn't work out the first time. So it put onto the screen the string representation of val. Here, let's make this a little more clear because I think it's getting print. And I want to put a bunch of dashes, and maybe this will sort of help you see how this is running. I'm going to hit run again. Run again. Oh, I got to scroll down. Sorry, that's my fault. Okay, so here it is. I put onto the screen the shapes 1, 0 as a string. It turns out it's already a string, so there's no change that needs to take place. Next, I want to put onto the screen the integer representation of that. Well, that's kind of tricky. Keep in mind that your screen is shapes. So it's taking the integer, the number, the quantity, turning it back into the shapes that you just transferred it into, and then putting it back onto the screen for you. So that's it. It's just understand it's useful to be able to, this is like typecasting in Java or in C++ or something like that. It's useful to be able to do that. Next, hex is taking the integer representation of the string value and turning that into a hexadecimal representation and putting that onto the screen. We see 10, 10, 0xa, then followed up by a line full of dashes. We've done all of the code in this block of code. Let me come down here and put print done, right? Just for the sake of proving that this is the way that it works. It's not ever going to print this done until it's done everything it can to this through this entire loop. So I'm gonna hit run again. Let's see how it does. Okay, here we are. We have our 10. We hit the next value, which happens to be 13, and that happens to be OXD. We hit the next value, and I'm sorry, followed by our line of dashes. We hit the next value, which happens to be 37, which is 0x25 in hexadecimal. Then our last value, 1337, which happens to be 0x539. And then once it's done all of that code, it's done down here, okay? So that's our for loop. I think we have a good understanding of how that's going to work for the time being. For every item in the list of items, that's how you say that line on line 24. All right, let's move on to the next slide, a while loop. So while loops are for when you are unsure of how many times something will run. A for loop is generally when you know how many times something is going to run, or when it is knowable ahead of time. So a while loop here, I equals 0. This I is just a placeholder value. It could be called anything I want it to call. Conventionally, when you see just a bare I, it's like for index or increment or counter or something of that nature, just I. When you see while, the current value of I is less than the length of the list of things, I'll say list of values here, because that's how many things, that's what I actually have. I have a list of values, not a list of things, right? So it doesn't make any sense to copy this because there is no bucket named list of things. It makes perfect sense in my world. I'm going to hit colon. Just like the for loop, that combination of colon plus 4 spaces, count them out, 1, 2, 3, 4. Again, technically it could be anything, just be consistent. But 4 is a good rule of thumb to sort of live by with that. All right, I'm going to print or put onto the screen the value in that row of buckets. And we didn't look at list indexing. And so this is where we're going to look at list indexing. I'm going to say list of values, square bracket. And this is just like indexing in Java. If I say in square bracket 0, that's the first item in the list. We're expecting to see 10. If I say square bracket 1, I'm getting the second item in the list. I'm expecting to see 13 all the way out to the end. So I'm going to say the current value of I. What's the current value of I? This time it happens to be 0. So the first thing I expect to see is 0. I'm sorry, is 10 right here. Let's run it and see what happens. We're in an infinite loop. Notice my bar is scrolling right here. What can I do to fix this problem? I've created a logic error in my code, and it is allowing me to, or it's not allowing me to regain control of my computer. Control C. Control C is not going to copy in Linux. It's going to, in PowerShell and Windows as well, it's going to kill or cancel your job. So I'm in my terminal down here that's built into Visual Studio Code. I'm going to hit Control C. And you'll notice that all of a sudden, I've got all this information back. It says, oh, trace back. It says keyboard interrupt, print value, list I, so on and so forth. Just understand when you see that keyboard interrupt, I've interrupted my program from running. I've canceled it. I've killed it. It's not running right now. How do I fix this logic bug? I need to increment I such that at some point in the future, it will be greater than, or I mean, this condition that needs to be met, this while condition, at some point, when this is no longer a true statement, it's going to skip running all the code to find them there. I is assigned the results of the expression I, the current value of I, plus 1. Take the bucket I, put into it the current value of I plus 1. That easy. The current value of I happens to be 0. 0 plus 1 is 1. Put that back into the I bucket. Ask the question, is I less than the length of value? The current length of list of values is 4. Is 1 less than 4? That's a true statement. Therefore, we need to do lines 33, 34, and because we don't have our indentation on 36, we are not part of that scope, so it's not going to run until after the fact. So what I'm going to do here is push my green button and see what it does. Boom. All right, cool. We see 10, 13, 37, 37, 13, 37, and then the word's done finally. We still see 24 through 28. They're still in play. How can I take them out of play? I highlight them, and then I can do like a mass commenting with Control/. Okay. So this is my while loop in Python. While some condition is true, the current value, while some condition is true, do this code. This code is pushed over by at least one layer of indentation. Okay. That's the while loop. All right, where are we at? I think we've been here. Yeah, we've been here for a little bit. All right, conditionals. Okay. All right, this one is pretty straightforward. This is all about, what's the word? Truthiness, okay? Is this a true statement? Otherwise, do this other block of code. If this is a block of code, if this statement is true, do this. Otherwise, do that. And then we have a more complex version of the if-else block, and I'll demonstrate those here. So let's see, we have, I'm going to take this out of play because it's not really all that interesting. Let's see. If, let's see, the len of, do I have my list of values? I do. If the len of the list of values is less than, let's see, if it's less than 5, let's say, put onto the screen, that's a short list. Otherwise, how do I signal otherwise? Else, semicolon. Or I'm sorry, not semicolon, else colon. I hit enter, notice it's going to push me over automatically. If for some reason I wasn't pushed over automatically, I need to add 4 spaces. 1, 2, 3, 4. Print. That's a long list. How many items are in list of values? 1, 2, 3, 4. What's the len, the length of list of values? That is counting them, just like I did. 1, 2, 3, 4. This whole thing is like saying, is 4 less than 5, right? Except the program can tolerate my changes dynamically, right? So if I add a new value here, I don't have to rewrite this line of code. Okay, so let's save it. Let's run. It says that's a short list. Excellent. What if I want a medium list? How do I signify that there's a medium list? How do I check if the medium list exists? You can use a more complex structure, what they call the if, elif, else. Let's try this. If, and notice that I backed out because they're all like siblings, right? And they all have their own area of responsibility, their own scope, if you will, their own block of code. If, if, I'm saying else, if len of list of values, say that if it's less than 5, if it's greater than or equal to 5, I'm sorry, yeah, greater than or equal to 5, and the len of the list of values is less than 10. 10, yeah, there we go. I noticed I put that colon right here. Go, boop. I'm going to put print. That's a medium list, right? So, wow, that's a lot of stuff going on in this line. I've introduced several different things. I've introduced this and. Well, we already learned in computer science praxis, and both sides of it have to be true, or one side of it has to be true. Right here, I'm saying if the length is greater than or equal to 5, and it's less than 10, both of those statements have to be true statements in order for this piece of code to work. If this piece of code works, it does not even ask this question. If this piece of code if it fails, if this is not a true statement, it will ask this question. If this question is not a true statement, it will finally do this statement right here. Last thing. This is like the statement of last resort, if you will. It's going to always run this block, or this block. It will never run 2 of them. It will only run selectively 1 of them. So that's conditionals really quickly. We never ran it though. We don't know if it's a medium list. And it's still going to be a short list. So let's add one more item. OX cafe. Oh, let me do this right here. Whoop. That happens to be a valid hexadecimal number, in case you were curious. I'm going to save it, run my code, and it's telling me that that's a medium list. I'm going to put it onto the screen so we can see print list of values. Notice I'm putting it before I'm asking the question, so I expect it to show up before any of these statements. I expect to see my list of values before I see that. Top to bottom, left to right, following the rules along the way. Put it onto the screen. There you go. Let's see. Save, run. Here's my list of values. Wait a minute. I put OXCFAE, but I see on the screen 51966. Well, integers are kind of close to a primitive data type. So it's going to take that hexadecimal value, turn it into a base 10 integer, and put that onto the screen, not the hexadecimal representation of it. That's something to keep in mind for that. Then eventually we see that's a medium list, and we're done. That's the last line, line 46. What's next? Function. Let's define a function. Okay. I'm going to take this code right here. I'm going to comment it out. Right now, if I were to hit run, if I were to save this and hit run, what do I have happen on my screen? I just see the word done. None of these green lines have anything to do with the code right now. I've taken them out of play by highlighting them and doing that mass commenting with Control /, right? I'm coming down to the bottom of my code right here, line 44, it looks like. I'm going to define a function. How do we define things? I def them. I define a function whose name is some cool function. Notice these aren't spaces, these are underscores, right? You can't have a space in most coding stuff, whether it be a variable name, a function name, so on and so forth. I'm going to use my open and close parentheses to signal again that there are parameters. It just so happens that there are no parameters, right? Here's my list of parameters that I expect. Just so happens I expect no parameters. Purely coincidental that I expect 0 parameters. I'm going to use my, there's a convention here. You'll notice there's a colon and then a layer of indentation. That is very common. Anytime you see a colon, you ought to be pushed over. One layer of indentation. So some cool function. In our example here, we have a function name defined, named func0, F-U-N-C, number 0. We have something called some cool func here. If I type func0, do you think that's going to do anything? We didn't define it anywhere. Of course, it's not going to do anything. It's going to be print. What is our function going to do? We're going to put onto the screen 2 to the power of 16. 2 to the 16th power. We're going to take that, do this mathematical calculation. Notice we didn't really cover about this. Asterisk, a single asterisk is multiplied. 2 asterisks is exponentiation. Okay, so this is like, rather than saying 2 times 16, this is 2 to the power of 16. Difference there. All right, so I'm going to put onto the screen the result of this math assertion. Okay, and that's it, really. That's all I have to do to define some function. All I've done is define what happens when I say some cool function, open, close parentheses. So let's save our code and run it. Why don't we see right here is kind of what I'm expecting to see, some cool function. I'm expecting to see either those words or some math. I didn't tell it what to do. It's not enough to just call the function. I have to invoke it. So let's try it now. What's it going to do? Nothing. All right. I'm going to invoke the function finally, right? I just said, hey, there's a bucket called some cool function. Now if I hit run, now I have a value. I have the value 65,536. That is put onto the screen. This function says, okay, go through the wormhole. When you land in that foreign galaxy, do this. Put onto the screen 2 times 16. Just so happens that's the last instruction. Go back to the galaxy from whence you come. That is line 50. Carry on. We see done. We see done. That's man, it's in my mind, I see a clear line between those two things. It's top to bottom, left to right, following the rules along the way. When you see a function name after it's been defined with parentheses, you need to go and try to do that function. That's part of following the rules along the way. Okay. All right, so let's see here. We were defining a second function. This is worth noting and harping on as well. I've been harping a lot, I'm sure. Def some other function. All right. Again, these two names are not the same thing. They don't do the same thing. I don't expect them to. I'm going to say return some value. You only return from inside of functions. I want to return to the 8th power. All right. And now I have to say, we already learned our lesson about invoking. So I'm going to say some other function. Let's invoke it. I expect to see 65,000. I expect to see, what's that going to be? It's going to be to the 8th power is like 1024. I don't know. I can't do math right now. Let's find out. That's why we write code, to it can do our math for us. Oh no, that's not the answer we were expecting. Why not? Because we got this value, and it's almost like we could scratch this out and replace it with 2 to the 8th. Okay. That's perfectly valid Python, but we didn't tell it to put it onto the screen. That's the problem. I'm going to undo this. We have to tell Python to do something with that value that was returned to us. Print onto the screen. Notice I put spaces right here, and those spaces will help me as the human, not the computer, me as the human, see and keep track that I have the appropriate number of parentheses. Occasionally, it's easy to sort of forget. If you end up with you might be doing several things. If you had taken the hexadecimal representation, you might have several of them. It's easy to sort of get confused as to how many am I supposed to have in here. So, all right, so now what are we doing? We're going to try it now. We're going to save our code. We're going to run it. I see, oh yeah, 256. I'm sorry, why did I say I couldn't do that? I totally knew that answer, to the 8th power, duh. All right, at any rate, I put that value onto the screen. I invoked the function. The code runs, and it does everything in parentheses first. Remember, it goes into the wormhole, and when you see return, keep in mind that that's like scratching out this value and replacing it like that. Now, Python still, you're inside of parentheses, so it's got to do everything in parentheses first. It's not simplified, if you will, or reduced, if you will. So this is going to be that 256. Well, there's no simpler representation of 256, so it puts that onto the screen. Okay. All right. No output Y. This is us just kind of talking through that again. I'm sure we'll be doing all of that in the class too. So let's see, functions part 1. That was functions part 1. Here are functions part 2. This is going to be helpful for reading other people's code and writing code that you get to reuse. I'm going to go ahead and blast these. I'm not even going to comment them out. Well, actually, I'll go ahead and comment. I was going to just delete them, but I'll leave them in there. All right, so let's see. We're going to take multiple types of parameters, what they call positional parameters, where order matters, kind of like long division, the number on the outside versus the number under the little L thing, right? Order matters. You can't just put the numbers in there any way you want. It matters in which direction they go. When you have positional arguments, when you have keyword arguments, the order doesn't matter. Nice thing that Python does for you. So not true of many other languages, but or other languages, particularly Java or C++. It's not true of those languages, but it is true of Python. It's a very friendly language. I like it. Def. Let's create a function called say hello. Say underscore hello. I'm going to create a bucket called name. What do you think name is supposed to represent? Some name of something, right? Enter, and I'm going to put onto the screen. And here's a trick we're going to learn about, and I guess you're kind of seeing it right here. Now that I mention it, you can put onto the one line at a time multiple things. You can put on the string hello, comma separated values, name. Right. So I expect to see the word hello and then whatever is in the bucket name. This is kind of like a bucket that only exists inside of this function. This name bucket only exists inside the function defined hello, or say hello. So let's do this. Say hello. All right, is that enough? No, it's not. If I want to use the function, I have to put parentheses. I'm going to hit Control Save and run. Why didn't it work? My code is telling me, my tool is telling me what's wrong. It says on line 63 in my learningpython.py file, line, say hello, type error, say hello is missing one required positional parameter or argument, name. Okay, well, what does that mean? Does it make sense to try and put in just a number? Will that work? Technically, it will. Let's see what it does. But it's not an accurate representation of our intention. When we say hello, we don't say hello to numbers. We say hello to people, right? So I'm going to say hello, Eli. And I see hello, Eli, show up on the screen. But I also see hello, 7128. Right? Python doesn't care what you put in the buckets. If it can put that value onto the screen, it's going to put that value onto the screen. It's not asking you, does your program make sense? It's doing what you tell it to do. And what you've told it to do is put something onto the screen. It knows how to do that. That's why it showed up that way. All right. And then, of course, we get our last statement done right here, which we keep leaving in place. Okay, so that's one argument. What happens if we want to say hello multiple times? Def say hello again. Okay. Let's see. This is going to be interesting. This function allows you to encapsulate and wrap up pieces of code that you're going to reuse more than once. So I'm going to say hello again to the name, and I'm going to ask how many times I want them to say something. Or actually, rather than say hello again, let's say hello in underscore times. And I'll call this in. I'm going to say name and in. I'm expecting two parameters. I'm expecting a name, a person, and how many times you want me to say hello to that person. How do I make that happen? I'm going to use a colon. I'm going to come in 4 spaces. I'm going to say for every I in the range of 0 to n, all the numbers, all the whole integer numbers between 0 and n, for every I in that list, do something. What is that something? I'm going to print hello. That's what I said, right? Hello, comma, name. So this part is new. We haven't seen this part yet. This just basically kind of creates a sequence of numbers, and it's for every item in the list of items. Remember that? For every number in the list of numbers. That's what this range represents. Let's create this in a different way. So let's say list of numbers is assigned the result of range. I'm sorry, it's a list of range 0 to n, the current value of n. Does that make sense? I want to see all the numbers from 0 up to 30. I want to see all the integers from 20 up to 200, right? Okay. So list of numbers for every number. Is that a little easier to tease apart, maybe? We went through a lot of typing. I think it's easier conceptually just to remember that range kind of gives you this functionality of this whole thing right here for free. In my mind, it's easier to, I'm comfortable with it. But if it helps you understand and to drive it into your head that there is for every singular item in collection of items. That's really all we're getting through with the for loop. Do something, right? So let's save that. What am I doing here? All right, I think I've saved it. Let me, if I run it, oh, I didn't actually call this function. Let's try that. Say hello n times to Bob, okay? How many times is n? Let's look at this. Oh, here's my tool coming along and helping me. I have the first parameter is the name. The second parameter it knows is n. That's all it knows. It doesn't know what n represents or what you're supposed to do with n, but I'm gonna say 5 times. I'm gonna put that in there. How does this work? Why does the letters Bob not end up in the n value, right? Because it's kind of like a positional mapping. The first parameter passed is placed into the first parameter defined. The second parameter passed is placed into the second parameter defined. I'm gonna hit save, I'm gonna hit run. Let's see what happens. I see hello Eli one time. And then I have a list of numbers and I see this hello name show up 5 times. Why didn't it show up 50 times? So I didn't say 50, I said 5. I said for every number in the list of numbers, list of numbers is defined as the range of integers from 0 up to n. I see 1, 2, 3, 4, 5. And finally, we're done right here. Boom. All right, what's next? We have, that was functions part 2. Oh, I didn't show you these optional or keyword arguments. Uh-oh. I hope we didn't. All right, yeah, there we go. Cool. Let us come down here and see what we can do. Let's create a new function that allows us to hello somebody, right? Def say hello default. That's what I'm gonna do. I can say name, and then I can give it some default number. I can say I want it to say hello some default number of times. N equals 1. Now if I can kind of copy this code, really. I'm going to do that. I'm going to copy this because it's really identical code. There's nothing different about this function and this one, the guts of it. But what it allows me to do is if I leave this n off, it's going to assume that n has a value of 1. So let's try that real quick. Say hello default. I'm going to say hello Charlie. Save it. I have Charlie saying hello 1 time. All the values between 0 and the current value of 1. Because I did not specify it, it's assumed to be 1 by the program. So all the integers from 0 to 1 is a list containing 1 item. So it's going to do everything for all the list of numbers or for every number in the list of numbers, which happens to be 1 item, this. Put on the screen hello and the current value of name. It's that easy, right? It's doing everything we tell it to do and nothing more. What if I want to say hello to Charlie 4 times? Here. I copied that line. I'm coming here. I'm going to say n equals 4. What did I say? 4 times? I did. Let's see what, or actually let's say 2 times, right? So we'll see a total of 3 Charlies in there. I'm going to say save that, run it. I see hello Charlie. Hello, Charlie. Hello, Charlie. Same thing, right? I've added some dynamic ability to my code, right? I can choose to do it kind of an optional number of times, but you know it has this nice default behavior. All right, so that's functions part 2. Do we have functions part 3? We don't. Okay, we are collecting input from a user. What does that mean? What? Okay, so now we're getting some interactivity in our programs. Check this out. I'm going to create a bucket called name. Oh, actually, let me take all this code out of play. Remember, I'm going to highlight it, Control/. And I guess I'm going to give this to you at the end of it. Maybe I'll post this as like a link on GitHub or something for you, just for you. I'm going to create a bucket named name. Name is assign the results of the expression, which happens to be the call to a function called input. Input. And it looks like it's asking a question. It says, what is your name? What is your name? Question mark. And so that we're not, I mean, you guys already know where this is going. I can really copy this. I'm just literally going to copy this. Let's copy it. Boom, boom. How is this going to work? I expect to be asked a question you probably have gathered that this is going to it's going to put this onto the screen, and it's going to wait for me to type something. What is it waiting for? It's waiting for me to hit the enter key. I can type whatever I want. It doesn't matter if I type my age when it's asking me for my name. It doesn't know contextually what a name is or an age is or your mother's maiden name or any of that information. It's just waiting for the enter key, and it's going to put whatever you give it back into a bucket. It's going to put the words hello plus the value of that bucket onto the screen. It's going to ask me for an age, and then this is new, an F string. So F strings are fancy formatted strings. They allow you to use this curly brace notation to write Python code that runs before your string is put onto the screen. So what does that mean? It's taking, again, when I type 30 or 3, oh, I'm almost 3 or 33, 33 onto the screen, it doesn't know that that's the quantity 33, much less it doesn't know that I was born in 1988. It doesn't know anything about that. It just knows the shape 3, and the shape 3 was hit on the keyboard and put that into the bucket. I'm taking it, treating it like an integer, that 33, that quantity 33, I'm subtracting 65, I'm sorry, subtracting it from 65, and then putting the results of that expression into this string. And you'll see this is a retirement calculator. Congratulations, good job. Thanks for your service. I'm gonna hit run and let's see what it does. Notice down here, it's not doing anything until I've answered the question, what is your name? My name is Eli. And some other stuff. Now, I'm not going to do that. I'm just going to put Eli, and I'm going to hit the enter key. And it says, hello, Eli. Notice that there's not a space. Why isn't there a space? Because I didn't tell it to put a space. That's bad on me. I should have done that. Now it's asking, what is your age? Question or no question mark. Why isn't there a question mark? Because I didn't put a question mark. That's bad on me. I should have done that. Let me update these slides. So let's put an age in here. I'm going to put 33. And it says, I have 32 years until retirement. And then we finally see our line, our famous line done at the end, top to bottom, left to right, following the rules along the way. When you see this input function, that blocks the rest of the program from running until you've hit the enter key. Everything you've typed up until you've hit the enter key is then put in the variable that you're assigning it to. Okay. So just kind of, that's a very useful tool. All of a sudden we can write cool tools to do temperature conversion for science class or something like that. Or we can target a particular server by typing its name that we want to attack in some form or fashion. So that's collecting input from the user. Dictionaries, man, dictionaries are cool. We'll spend a lot of time messing with dictionaries because it is probably one of the more common data exchange formats. It's called JSON. How you get programs, information from other programs is you'll want to send them through the internet. You're likely going to use something like JSON, some serialization format. So let's see. Our example here is an animal. In animals, we have the key and then we have the value on the left, right? Just like a dictionary that we have words with definitions, we have our defined word in bold, and then we have the parts of that define what that word is. A horse is a four-legged creature that neighs and eats hay and things like that. You know, a bicycle is a device that allows you to move throughout the world using two wheels. That's a bicycle thing, right? That's a key. The word and its definition, its value. Okay, so what are we going to do? We're going to create a user dictionary, a list of a thing that describes what a person is. The Eli dictionary, right? And I'm going to create true facts about myself. I use curly braces to define a dictionary. A dictionary is different than a list. It's kind of like a named list, where rather than using the bucket number, you get to use a name, a piece of masking tape on that bucket that has words that you recognize as a human, not just an index in an array. So I have a a bucket within this Eli dictionary called age. And my age is 32 right now. All right. And again, it's just like comma separated values. I have key colon value. This is like maybe one exception to that colon rule, like with the if statements and the else and the while and the for. This is really just kind of like separating the two, the key and the value. I'm going to come down. I'm going to say, and again, notice I'm using single quotes here. I can use double quotes. I can use different values. They're tricky. The various types of things you can put in there. I would say stick to using double quotes. So I'm going to change these back to double quotes because that'll make it easier when you're working with JSON, because JSON only understands double quotes, not single quotes. So age, let's see, height, right? And I am 71 inches. Why did I not type 71 space inches? One, that's not like a valid Python thing. It's not a valid programming thing. I could put it in quotes, but it might be that I want to do some calculation with it. And that would be difficult if it's in string format. It's more difficult in the string format. I can treat it like just a regular number like that. I could say 71.5 inches, right? That allows me to do math to say you're not tall enough to ride this ride without adult supervision or whatever. So notice that I did that same trick about putting things on multiple lines that I did with a list. I have my open curly brace, closing curly brace, and I'm pushed over one layer of indentation. I can do it all just like this. Oops. In my mind, that's visually cluttered and confusing, and it's harder for me to like understand what that is. It takes more effort. I prefer to see them this way. Both ways are correct. Okay. So what do I want to do? I want to put Eli Dictionary onto the screen. Print. Python's really cool. It just lets you dump stuff onto the screen in the way that makes the most sense. I'm going to save that. I'm going to run it. Cool. We looked at those F strings a second ago. Look here. I want to look at the Eli's age, right? And I can make sense of this statement here. Let me put onto the screen. It's an F string. Eli is, I use my curly brace. I'm going to say Eli Dictionary. Then I use my square brackets, kind of like a list where I'm indexing by a number into there. Eli Dictionary, and I'm going to say open quotes age. It has to match this, right? So if it's in quotes, it has to be in quotes here. Age. Oh, sorry, I guess years makes more sense. Eli is 32 old, doesn't make sense. Eli is 32 years old. So this whole line, this whole highlighted segment is going to get replaced with the value in the Eli dictionary associated with the key age. That value happens to be 32. So it's like, you can highlight that and it gets replaced with that. That's what shows up on the screen. Okay. Let's see. Let's copy that line. I'm going to put a new line onto the screen. Is inches tall. And then rather than my age, I'm going to do HEIT, height. So Eli is so-and-so old and so tall. Let's see what happens. I expect to see 32 and 71. Okay, so I'm going to run it. What is your age? Oh, man. Eli. 32. All right, cool. I forgot that I was still asking that information. And I forgot, I guess I ran it and I never looked at it. Sorry about that. So we see, we've put onto the screen 32, height 71, 33 years to retirement. Let's run it one more time. Run. Why is it nothing on there? Okay, it still asked me for my name. Oh, because I didn't tell it. I am Eli. My age is 32. Eli is 32 years old. Eli is 71 inches tall. Notice that this value has nothing to do with this value. I say notice, maybe it's not clear. It's simply a coincidence that I put the same values in there. If I run it again and I put in different values, let's do that. I'm gonna say my name is Bob. Oops. Bob. My age is, 43. Eli is 32 years old and 71 inches tall. 22 years to retirement for old Bob, right? One thing that's interesting about dictionaries is right here you can have a list of other objects, other data types. There's a value that happens to be some other collection. It can be another dictionary. It can be a list like is demonstrated here. I'm going to say, I'm going to have a list of favorite movies. Fave movies. Like that. How do we define lists with our square brackets? Just the same. It's exactly the same here. There's nothing different about this. I'm going to say Hackers is probably among my favorite. I'm going to say, I don't know why. I'm going to say Men in Black. That's fine. In Black. I like Will Smith. And I'm going to say, what else? Oh, gosh, I can't think of another movie. Any movie. Titanic. I don't know. That's all I could think of, really. I'm so sorry. Those are my favorite movies. And I'm just going to print onto the screen, Eli Dictionary. And again, look, I'm not wrapping it in this fancy formatting thing right here. There's more than one way to get access to this data. Fave movies. I expect to see those three things in that order. My name is, doesn't matter. My age, 23. All right, I see Eli's 32, 71 inches tall. Here's his favorite movies in that order. Cool deal. I'm going to take this, comment it out. That was the thing that was prompting us for our name and our age. Now we're messing with dictionaries. So, all right, where are we at? Where are we at? That is dictionaries. Complex data structures made easy. Remember, key value. Key is on the left. You address it by that name, and it has to be in quotes. Oh, I say it has to be. Generally, it's going to be in quotes. Let's see. Oop. Reading and writing a file. Oh man, this is cool. All right, it's 4 o'clock. Gosh. All right, here we are. Reading and writing a file. Python it makes this trivial, man. In Java, if you've messed with it, it's like you've got to have buffered readers, buffered writers, all these things. Python, it's pretty straightforward. I don't have these test files. I need to create one real quick. Let's do that. I'm going to go ahead and create a new file because I feel like 100 lines is a lot. This has become too big of a thing for one thing. I'm going to close it. I hit my little X. I'm going to create a new one. I'm going to go File, New File. I'm going to select a language, kind of like we did before, Python. Boom. And I'm going to save this one as Learning Python Part 2. Part 2. Okay. All right. So I need to create some test files for us to look at. I'm going to go to File, New again. And this time I'm just going to hit Don't Show This Again. This is just a regular text file I'm going to create. I'm going to create a list of things. I'm going to list of animals, dog, bird, elephant, hippo, a blank line, turtle. What else do we have? Kangaroo. I don't know. I'm going to save this. I'm going to save it as a file called animals.txt. Okay. I have a list of 7 or 6 animals with 1 blank line in there. That blank line is just to show you something here in a second. It looks like this is what we're going to do. This is what we're going to do right here. Boom. I'm going to create a file. My animals file is assign the result of the expression open, the function open, and then you have to tell it what file to open. This is what they call a relative path. Because the files are next to each other and they're in the same folder, I can just type animals.txt, animals.txt, and I have to tell it whether I'm reading or writing the file. I'm reading this file, so I have to put in the quotes R for reading. That's it on that line. That's all I need to do. The next thing I'm going to do is I'm going to say for every line for my animals file.read lines. What is that going to do? For every line in my animals file.read lines, this is going to get all, this is like having a list of lines in the file. It's in the background, before it gets to this, it's going to say, all right, open up the file, read all the lines into memory, and then start looking at them one at a time and do all of this code that we define for each one of those lines. What do you want to do with it? We want to print line. Let's start with that. Let's see what it does. I'm going to hit the green go button. All right. So it looks like I have a dog space, bird space, elephant space, hippo space. Why do I have all these extra, and then a space, turtle space, kangaroo space? I have all these extra spaces because I've told this file, I told you earlier about bytes. It's actually reading that new line character. There's a trick you can use to strip off the extra characters, the extra white space or the new line characters. If we run it now, we shouldn't see. It should look kind of like it does in this file here, right? I do believe it also trims off the leading space as well. So let's try that again. I'm gonna come over here and run it. Yeah, see, you could sort of think of this as like cleaning up the data. It pulled off the extra spaces at the beginning as well as the extra spaces at the end. That's what strip does. It strips away all the extra white space. So this is something on line 4 I didn't do here. Notice my program worked just fine, but it's a bad programming practice. What do you do when you take tools out of the toolbox and you're done using them? You put your tools away. When you open a file manually like this, you should close that file, my animals file.close. You're signaling to the animals file, the thing that you've opened as that, to close. That's what that represents. Okay. It looks like this right here. It says new file. We're going to create a new file. We're going to add to the file. Let's try that. Some new file equals open more animals.txt. And because we're writing, this time we're going to add to a file. We're going to write to a file. I'm going to use W. And then it shows here, it says new file.write, and then this is the new data in the file. If you had to guess, what do you think is going to land in that new file? This is the new data in the file. That's what's going to show up there. Some new file.write. I'm going to say, what do I want to say? I want to say, oh gosh, what's another animal? Yak. I don't know. Yak. I'm going to say bison. Ugh. And then I'm going to show you this /n, this new line character. Hopefully that's going to put a new line. So I'm going to see yak and bison on the same line, and then I'm going to see a wren. Ugh, I don't know. On a line by itself. I'm going to hit enter, and then I'm going to close that file. Again, when I open something and I'm done with it, I'm going to put my tools away. Some new file.close. Save. What happens if I run this? Do you expect to see this show up on the screen? I don't. Boom. Well, how can I find out if that actually worked? If there's now a file called moreanimals.txt? I don't know, I can look. I can try to open it. Looks like there is a file called moreanimals.txt. It has 17 bytes in it. Let's see what it looks like. It looks like I have yak and bison on the same line. And because I use that fancy /n, that new line character, I have a new line right here, new line with ren by itself. Okay, so that is opening, reading a file, writing a file, two very useful skills. All right, so where are we at? Oops, let's see. I was reading and writing a file, error handling. Can you divide by 0? No, you cannot. How do we know that? I'm going to take these, I'm going to Control C them and like take them out of play. Or not Control C, I'm sorry, Control /, take them out of play with a mass comment. All right, so 0 division error, divide by 0, you cannot do it. You can see that this is me just kind of playing around, and I guess I'm showing you this here. There's different kinds of errors that exist. There's a 0 division error, that's dividing by 0. There's file not found error, so if you cannot find a file. There's new connection error, if you cannot create a new connection, right? The errors make sense. The names of the errors are telling you kind of what's going wrong with the program. So let's try, how do we handle that? How do we account for doing risky things? How do we do dangerous things safely? We can show this right here. This is one example. Actually, hold on, let's do this. Using a file. Rather than using the 0 division error, you're not likely to intentionally divide by 0, but you might try to open a file that doesn't exist and you want to tell your users that it doesn't exist. So let's do that. Let's revisit our open animals file. So I'm going to try to do something. Actually, no, let's try to, let's show it what it does without this first. Let me do this. Other animals. Is there a file named other animals.txt? Other animals.txt. There's not. ls. I do not see an other animals.txt. I'm going to save it. Oops. I'm going to run it. Boom. File not found error. Error number 2. No such file or directory. Other animals.txt. Right? How do we account for that in our code? We can try to do dangerous things. Try : anytime we see that colon, what do we generally add? We generally add a layer of indentation. And we define all of our behavior that we want to happen inside of that try block, what we call the try block. Except this is how we define if there is an error of some sort. I'm going to highlight this. It's the file not found error. You can type it out here, and it matters that you type it like case sensitive, like this isn't a thing. You have to have a capital E. File not found error. Colon. So here you're defining function, you're defining behavior based on a certain set of conditions. Try to do all of these things. If anything goes wrong, particularly if you cannot find the file, this is what I want you to do. Rather than continue on, like if you find that you cannot locate this file, show me that you can't find the file, and then exit the program. Run. The file was not found. And then notice that we simply exit the program. Oh, we need our done down here. Print done. That would have been more powerful if I'd had that in place beforehand. Let me get rid of that. Let's see what it does this time around. The file was not found. Done. Notice that it runs all of this code and then steps on to the next line. When I put exit in, imagine something down here on line 15 through whatever relies on having read some animals from my file. There's no point in even trying to run that code, right? It's not going to work. So you might as well exit and let the user fix that problem. Okay. So let me save that, and now let's witness it again. Boom. We do not see done because we're told to exit our program gracefully. They call this like graceful error handling. Rather than letting your program crash, you're trapping these exceptions and having a good time doing it. I guess. I don't know. So this is more of us exploring the zero division problem. I think the file not found error is maybe a little more useful. Say you were trying to do some scientific program, or you were trying to load in a bunch of targets to hack, and your program is expecting to open a file of certain that contains lists of servers and usernames and passwords and such, and it can't find it. Rather than trying to hack nothing, just tell the user that it's broken and move on. So that's us playing with error handling in the slides. Python libraries. Okay, cool. The standard library in Python is composed of, oh gosh, I don't even know how many different libraries, and it's generally pretty useful, but it's not always the best designed, right? Or it's not always the most developer friendly. That's where these third-party libraries come in. You can do just about everything using the standard Python library, but if you want to have an easier time doing it, you'll want to consider using the third-party libraries. In this PD, we're going to use requests. We're going to use Flask. We might use the Google library. I forgot that I added that on there, but there it is. And we're going to use those to have an easier time sort of answering the higher level questions we want to ask. Go to some website, download some information, as opposed to creating a bunch of arcane, just kind of incantations that do things. It makes it a little more easily read. How do you get these third-party libraries? Well, at the command line that I was talking about over here, right, earlier, I guess, and some other point in time, I was talking about the Linux command line. We pip3 install some library. Pip3 is for Python 3, pip is for Python 2. Pip or Python 2 is no longer a thing. It's not supported anymore. You should avoid using it if possible. So pip3 install requests. And that should reach out to the internet, try to get requests. It turns out I've already installed the request library. Did I install request-html? I had not. Oh, no, I had. Okay, I guess I had installed request-html. Do I have Flask? I can try it. Flask. By the way, you can try more than one at a time. I'm going to say Flask and Quart. I don't think Quart's installed here. And so hopefully it's going to go download a bunch of things, and you'll kind of see, you'll see that it, this is what it kind of looks like. It's going to use little fancy toolbars and like progress bars and such, and it's going to download yada yada, and it says successfully install all of those things that I requested. Just so happens Flask was already installed. Quart is like Flask but different. Okay, so using Python libraries, the name of the game here is what we call like namespaces, right? So we're going to import, and I consider libraries very much like books. I use the cookbook analogy. So there's a bunch of recipes, and they're all organized into cookbooks. We can go and we can either grab the entire cookbook off of the shelf and carry it around with us, or we can go and pull out the individual recipes from the cookbook and keep those with us, okay? And so to pull the whole cookbook off the shelf, following that analogy, that's when we do this whole import library name, where library name represents the entirety of the cookbook. Anytime we want to get a recipe, we have to make a reference to the cookbook itself, and then using what they call that dot notation. We did that with dot upper, dot so and so, whatever dot was. That's just the accessor to that thing that we're trying to reach into, that variable, or in this instance here, that function. That's generally why libraries exist, to collect functions and other pieces of code that you get to reuse. So let's look at that. I think we're going to mess with Flask, likely. Oh, no, OS. All right, so we're going to do our operating system stuff first. Let's look at those. I'm going to do this. By convention, you do your imports at the top of your code. Import OS. And I'm going to comment out our try block, just like we did before. Import OS. I'm importing stuff related to OS. What is OS? OS generally stands for operating system. Stuff related to your operating system. Okay. Well, what can I do with that? I can print operating system list as in list directory. That's kind of like coming down here and list stuff. I expect to see something very similar to this. It might look a little bit different, but it should be mostly, it'll have the same content, I'm pretty sure. Control C, Control save. And if I hit the green run button, I'm going to put onto the screen the results of listing the current directory. Put onto the screen. Oh, wow, I see a lot more stuff. In fact, let's take this time to come over to our bigger terminal window, and let's learn how to invoke Python the way that big adults might actually invoke Python. I'm going to list the stuff in this directory. Notice that we're working on a file called Learning Python Part 2. I'm going to copy that. I'm going to type Python 3 because that's the language we're using. We're using Python 3. That's the tool. That's how this is going to know what to do with our code. And I'm going to type learning Python _part, and I'm using tab completion. We learned about that hopefully in the Linux lab. Learning Python Part 2. I'm going to hit enter, and now I can see a bunch more stuff. I see animals.txt. Oops, I'm sorry. See. I see animals.txt. I see tools. I see, oh gosh, word lists. I see downloads. Why do I see all these extra things? It's the same as doing ls-a. It's all the same folders. The only reason is by default, these periods hide files. Again, hopefully we covered that in the Linux lab. If we didn't, there's a little Linux stuff for you. That's true of only Linux, not true of Windows. All right, so I cleared the screen with clear. I'm using my arrows to get back. Learning Python Part 2. All right. So I've listed the directory. What if I want to list a specific folder? I want to look inside of my tools folder, /tools. I want to save that. This is, oh, I'm sorry, a relative path. So it's adjacent to me, so I don't have to use that slash. I can just have the word tools there. I'm going to go back over here, run it. Now I see that inside of tools, there's a folder called Veil, Ghidra, Covenant, gsocket, nmap, yada, yada. Well, if I ls tools, I have the same thing, Covenant, Ghidra, Veil, Silent Trinity, gsocket. It's the same stuff, formatted differently, formatted in such a way that I could use a list to recursively, or maybe not recursively technically, but sort of iteratively look inside of all of those files, right? This is a list for every folder in list of folders. Do something. Encrypt all the files like ransomware. Delete all the files like just really mean malware, right? Okay. So that's using the built-in libraries. We showed quickly how to install some libraries. Looking at this code, sleep is very useful for like timing things, particularly at the human scale. Timing things at the human scale, not at the computer scale. Let's see. I mean, it is useful at the computer scale too, because it has high resolution, but I'm going to import time at the very top. Import time. I want to access, oh, and this is, okay, so showing that mechanism. So let's look at that. Let's look at how it's telling us to do it, because I did that on purpose. From the time library, import the sleep function. That's how I would read line 2. From the library called time, pull in the function or import the function called sleep, right? That's how I would tell the story of that line. So I'm going to still list the directory of tools, but I'm going to put onto the screen, wait 3 seconds, and then put them onto the screen, right? How do I actually make it wait 3 seconds? Sleep 3. It's that easy. I'm going to hit run, wait 3 seconds, 1, 2, 3. Then it shows up. What if I wanted to wait 3.5 seconds? It'll wait 3.5 seconds, just fine. Why did it not say 3.5 seconds? Wait 3.5 seconds, because I didn't tell it to say that. It said wait 3 seconds, not wait 3.5 seconds. So let's update our thing to be more accurate. There's that. All right, cool. That was 3 seconds roughly. What do we have next? Using Python libraries. All right, so this one is really fun. We have the request library. If you have done that pip3 install request, you should be able to follow along at home. You can, I guess, kind of just copy and paste this and make it interesting, as interesting as you want it to be. I'm going to copy and paste it. Copy. I'm going to take those out of play real quick. And I'm going to paste that code. What does it do? It pulls off of the shelf the request library. Note that I didn't put it at the very top because I don't have to. Like logically, all of these lines, those are effectively blank. They're not going to do anything. It doesn't have any impact on the code. It's just there. Import request library, the library named request. Anytime I want to do something with that, with involving that, I have to reference that book specifically. And I'm going to say, I want to create a bucket called data, and I want to assign it the results of the request module dot function or dot get function. And it looks like I handed something that looks just like a website. http://shift.us. So data equals request.get shift.us. And then I want to put onto the screen data.text. If you had to guess, what do you think data.text is? Particularly in the context of knowing that this is like a website, the text of a website. Pretty straightforward. In 2 lines, I've downloaded the text of a website. That is what makes a website. There is a caveat. This is not the rendered text of a website. This is the bare HTML and JavaScript. It is and no additional JavaScript. It is just that one file located right here. That's not a problem for us because this is a pretty simple website. There's nothing else for you to pull in. It's just this text. I'm going to put that text onto the screen. And I asked the question, if this is the true statement, do this code. Is the string keyword somewhere in, this is a containment operator. It's kind of interesting. In Python, you can ask that question that way. You say, is this string in this collection of text, is in this sequence of text? Really what it's asking, is this sequence inside of this sequence? That's really what's happening here. If that's a true statement, it will put onto the screen keyword found in text. I don't know. What's at that website? Hey, that's me. All right. Is the word hacker in this text? Hacker. Maybe it is. Let's look. Save it. Let's run it. Keyword found in text. Where was it? Oh, okay. Well, you can see the entirety of the website right here, actually. Okay, it's somewhere in there. It did exactly what we told it to do. It went, fetched that content, put it onto the screen, and then answered the question, is this keyword in text? And it turns out it is. And then finally, we saw the word done. All right, keyword found in text, done. Well, that's super useful. What if I change this to msn.com? Keyword found in text. That means the word hacker shows up somewhere on msn.com. What if I did this every 30 seconds to keep track of news regarding hackers? News regarding data breaches or passwords that have been leaked, right? I've created a tool now that, oh wow, let's pull together 3 things real quick to do that. We have our time module that I think maybe I pulled in. I have sleep right here. We have a while loop. So while 1 equals 1, will that ever not be true? Ultimately, this is the same as doing this. 1 equals 1 is the same as doing true. 1 equals 1, right? Right. So I get to say while true, go to this website, msn.com. And I don't want to print the data every time. I just want to ask the question, is hacker showing up somewhere in the website? And then I want it to wait. I don't know. This is based on the number of seconds. Notice it says param seconds as a float, delay execution for a given number of seconds. This is the sleep function. This is coming from that sleep or that time library. I'm going to say wait 300, which I think that's 5 minutes. So wait 5 minutes and check again. Are hackers still in the news at that point in time? Hackers are found in text, are listed. No, that's not interesting. In the news. Safe. All right. All right. Hackers are in the news. Now it's waiting for 5 minutes. We don't know that because we didn't tell us. That's a bad user experience. Print, or actually, hold on, let's do this. So let's else print hackers are not in the news. That way we always have some sort of feedback. Print waiting 5 min. There we go. Boom. Now we've got some intelligence gathering utilities, right? We are now monitoring an internet website for activities of hackers, right? We don't know exactly what it is, but this is the most basic, rendition of that. Boom. What's it doing? Hackers are in the news. With any luck, and I can change this to 3 seconds to sort of simulate that process. Let me kill this again. Run. Boom. Hackers are in the news, waiting 5 minutes. Let's say 5 minutes elapses, and it's going to go, once this is done, it's going to go back up to the top, refetch the contents of that website, and if it's in there, now we'll look at request HTML. That'll actually do a lot more detail, and we can actually look for things as if we were looking at it in a web browser. What this is doing is looking at the, oops, I'm sorry, view page source. This is looking at the bare text. If I go to msn.com, and I right click view source, this is what it's looking at, not with all the pictures, not with all the other interesting stuff. It's downloading all of this information. Request HTML will allow us to look at it as if we were looking at it in a web browser. So, man, I think that's that. That's the end of it? It says, let's begin, as if we're about to jump into the first project or something. So, man, that's it. Yeah, we've built some cool tools. This was an impromptu thing. I'll save these off and I'll make them available to you. I hope that you find this valuable as a supplement to the instruction day of. If not, that's fine too. Thank you for being here. I appreciate it. We will talk to you later.